Hello, and before we begin, this material is provided strictly for historical, scientific, and cultural education. It does not encourage the cultivation, distribution, or use of cannabis in any jurisdiction where such activity is restricted. All modern cannabis activity remains subject to local, state, federal, and tribal law, and nothing here should be taken as guidance beyond documentary analysis. The history of foundational cannabis cultivars is not a story of brand creation. It is a record of how distinct populations of the plant developed chemical and structural traits in direct response to their environments, and how those traits later influenced modern breeding. When early landrace populations first appeared in documented trade routes, no one was selecting for flavor categories, phenotype marketing names, or consumer effect profiles. Farmers selected plants because they survived specific temperatures, wind exposure, disease pressure, and harvest conditions. Every surviving lineage shows the evidence of those pressures in measurable traits: resin gland size, leaf morphology, node spacing, and dominant terpene pathways. Before official breeding programs existed, these plants moved with people, not scientists. Resin-rich broadleaf forms leaving Central Asia were transported along hash, producing corridors. Narrowleaf equatorial expressions moved along coastal ports, used for spice and textile shipping. When seeds reached new regions, the plants often failed unless their biology already matched the new latitude, soil chemistry, or humidity range. Very few survived these transfers. The ones that did became the genetic anchors upon which all later hybridization depended. Chemical identity formed long before modern analytic tools could measure it. Myrcene-heavy expressions became common in arid and high-altitude regions because their resin composition reduced moisture loss and prevented oxidative breakdown during long storage. Terpinolene-dominant narrowleaf varieties concentrated in humid equatorial belts where aromatic volatility helped protect against fungal decay. Caryophyllene-rich forms were favored in regions where heat stress and soil mineral imbalance forced plants to produce additional sesquiterpenes as chemical stabilizers. The profiles people now associate with flavor and effect are the same profiles that once determined whether a crop failed or produced usable material. When these early populations eventually reached regions with controlled indoor lighting, their environmental history followed them. Plants that evolved under intense seasonal light shifts responded strongly to artificial photoperiod changes. Plants that evolved under stable equatorial days required more manipulation before they would initiate flowering. The modern hybrid era did not erase the biological record of where these lines came from. It reorganized it. Each cultivar discussed in this series carries forward a measurable fragment of that ancestry. The purpose of this work is to examine those origins at the level of structure, chemistry, and documented lineage, not nostalgia, marketing, or romantic narrative. The cannabis population originating from the Mazar region displays one of the most stable morphological profiles in recorded broadleaf lineage history. Its structure resulted from repeated seasonal elimination of weak expressions under conditions defined by low humidity, mineral-heavy soil, and significant temperature fluctuation between day and night. Surviving plants show consistent short internode spacing, thickened petioles, dense bract layering, and high trichome mass relative to floral surface area. Early botanical field surveys, conducted before widespread hybridization, recorded these traits with limited variation, indicating that stabilization occurred through regional selection rather than controlled breeding. Resin production in these plants aligns with traditional hash preparation methods used throughout northern Afghanistan. Myrcene commonly appears above 1 full percent by weight in samples grown under native soil conditions. Caryophyllene presence reinforces heat-softening behavior required for hand-pressed resin. Measured trichome head diameter is comparatively large, supporting manual separation without solvent use. Archival laboratory analysis of resin bricks exported during the 1960s demonstrates chemical consistency matching modern laboratory-validated reference samples attributed to pre-hybrid Mazar seed lines. Environmental data collected from this region indicates alkaline soils with elevated calcium and magnesium levels, minimal phosphorus availability, and seasonal atmospheric dust exposure. These conditions drive the development of thickened cuticles and increased resin production as a defensive barrier. Climate records show extended dry periods during flowering, followed by abrupt nighttime temperature drops. Populations unable to maintain internal moisture balance under these conditions did not persist, producing a genetic bottleneck favoring plants with strong resin coverage and tightly stacked calyx formation. Historical documentation confirms trade movement of this material into Persian and South Asian markets. Early written references describe resin by physical behavior during combustion, the pliability of hand-rolled forms, and durability during storage, not by cultivar names. Multiple independent accounts, recorded decades apart, describe identical handling characteristics. This reinforces that the chemical and structural traits remained stable long before formal cultivar terminology or commercial breeding frameworks existed. Chemical analyses conducted on preserved samples collected prior to 1970 show dominant sesquiterpene signatures and minimal presence of terpenes associated with equatorial plants such as terpinolene or limonene. This confirms that the Mazar population developed without genetic mixing from tropical sources. Every verified dataset supports the conclusion that this lineage represents a closed regional system shaped by environmental pressure, manual selection, and resin-based economic use, rather than hybrid manipulation. The earliest documented derivative line, taken from the Mazar population and stabilized outside its original region, was Afghani number 1. It first appeared in recorded circulation during the late 1970s as a seed line collected directly from northern Afghan stock and reproduced in controlled environments without outcrossing. Its distinguishing traits included a shortened flowering duration compared to typical Mazar expressions and slightly increased calyx density. Chemical testing performed decades later confirms that its dominant terpenes match the Mazar baseline. Myrcene and caryophyllene remain primary, with no introduction of equatorial aromatic markers. Its significance lies in being the first Mazar-derived line repeatedly reproduced outside its homeland while maintaining its chemical profile. The second established offspring line was Hindu Kush, identified as a stabilized population adapted along the mountain corridor stretching between northern Afghanistan and western Pakistan. It retained the same broadleaf morphology observed in Mazar expressions, but displayed marginally improved resistance to humid storage conditions due to slightly reduced surface resin oxidation during slow curing. Early chemical sampling indicates that its myrcene content remained consistent with its parent group, but humulene concentration increased measurably, likely due to regional environmental influence. This change did not alter its classification, but marked it as a distinct export variety. The third verified derivative is the early form of hash plant, prior to its later commercialization. Historical grow logs show that this line was favored for the density of its lateral branching and high resin-to-leaf ratio, which increased usable yield during hand processing. The trichome heads remain similar in size to those of the Mazar parent group, but a higher number of intact glands persist through drying compared to earlier expressions. This suggests that selection for retention of resin mass occurred intentionally among farmers handling large harvest volumes. The fourth recognized line is maple leaf indica, a direct descendant of Mazar stock associated with resin pliability. Documentation from early European collectors describes its ability to fold and bind during hand pressing without structural cracking, indicating a shift in resin lipid composition rather than terpene identity. Laboratory confirmation performed decades later supports this, showing slight increases in long-chain hydrocarbons while total terpene concentration remains consistent with the Afghan profile. Its value was functional. It allowed more uniform pressing and transport of finished hash. The fifth confirmed descendant is the original Northern Lights number 1, prior to hybridization in the Netherlands. When introduced to indoor cultivation in the Pacific Northwest, it retained the morphological and chemical markers of Mazar ancestry, including its broadleaf canopy structure and myrcene-dominant terpene ratio. The only measurable change was a visible coloration shift under cooler indoor night temperatures, producing darker pigmentation in late flower. No evidence suggests that this trait affected resin composition. Northern Lights. Number 1 represents the earliest point where the Mazar genetic framework entered controlled artificial lighting environments without significant structural or chemical alteration. Across all 5 lines, the defining pattern is preservation of chemical identity despite regional and environmental relocation. Each retained broadleaf morphology, resin density, and the same dominant sesquiterpene profile present in original Mazar populations. Differences appear only in processing behavior, maturation timing, or environmental suitability. These 5 lines form the documented foundation through which Afghan hash region genetics entered global breeding programs. Skunk Number One originated through deliberate combination of 3 genetically distinct cannabis populations: a Colombian narrowleaf cultivar, a Mexican narrowleaf cultivar, and an Afghan broadleaf hash plant line. The hybridization work was carried out in the United States during the mid-1970s by cultivators working outside formal agricultural institutions. Records from that period identify the Colombian component as a highland expression with extended flowering duration and elevated terpenoline content, while the Mexican component displayed faster maturation and lighter biomass structure. The Afghan line contributed dense floral stacking, reduced internodal spacing, and increased trichome production. The resulting population displayed traits not found in any single ancestor. Flowering duration shortened compared to Colombian stock, while overall biomass increased relative to the Mexican parent population. Resin production increased beyond what was typical in narrowleaf cultivars of that era, and the terpene output shifted toward a combination of ocimene, myrcene, and humulene. Early reports from cultivators indicate that the plant produced a strong airborne aromatic presence even before cure, a characteristic not commonly encountered among stabilized hash region lines at that time. Documentation from early breeding circles shows that Skunk Number One gained adoption primarily because it performed predictably under indoor lighting systems. At the time, many imported seed lines expressed unstable growth or failed to mature properly under artificial photoperiods. Skunk Number One responded consistently to controlled light scheduling, producing uniform branching and reliable resin development under fluorescent and early high-intensity discharge lamps. This performance established it as one of the first functional baseline cultivars for controlled environment cannabis production. Chemical analysis of verified early skunk samples shows that its terpene distribution diverged from the landrace populations that preceded it. While Afghan ancestors emphasized sesquiterpenes such as caryophyllene and humulene, Skunk Number One expressed elevated monoterpene content, particularly ocimene. The presence of ocimene at measurable levels correlates with the characteristic pungency historically associated with the cultivar. This distribution indicates that the hybridization did not simply merge traits, but produced a new aromatic profile, driven by compound synergy rather than single lineage dominance. By the end of the 1970s, Skunk Number One existed as a maintained seed population distributed among underground growers in the United States. It reached Europe in the early 1980s, where it was incorporated into commercial breeding programs due to its adaptability and chemical consistency. Early seed catalog descriptions confirm that the line reproduced true to type across generations and showed lower phenotypic variability than most imported cultivars. These traits allowed it to become a genetic reference point during the first wave of recorded hybrid programs. Chemical profiling of authenticated early Skunk Number One material shows a terpene structure distinct from purely Afghan or purely equatorial lines. The dominant monoterpene present is ocimene. Laboratory samples archived from the early 1980s consistently show ocimene levels above 0.5% by weight in dried inflorescences, a value higher than most broadleaf cultivars of that period. Ocimene contributes to the aromatic output historically noted during late flowering and early drying. Myrcene remains present at measurable levels, but no longer functions as the primary aromatic compound, unlike in Afghan-derived material. Quantified research material collected in controlled indoor grows during the 1980s shows myrcene values ranging between 0.4 and 0.7% by weight. This concentration establishes myrcene as a supporting, rather than leading, terpene within the cultivar's profile. Humulin appears at concentrations similar to those measured in broadleaf ancestors, but expresses alongside elevated monoterpenes rather than dominating the profile. Its presence indicates chemical inheritance from the Afghan parent line. Controlled storage studies carried out on historic samples show that humulene oxidizes at a slower rate than Aussie mean, contributing to the stable secondary aromatic layer observed after extended cure. Caryophyllene remains detectable at levels consistent with Central Asian hash region genetics. Quantification of pre-hybrid archival samples places caryophyllene in the range of 0.2 to 0.4%. This sesquiterpene does not drive the primary aromatic signature, but confirms lineage continuity with the Afghan component used during the initial hybridization. Cannabinoid measurements taken from preserved research samples show tetrahydrocannabinol concentration in the 13 to 19 percentile when grown under lighting conditions common in the 1970s and 1980s, with ranges typically falling between 13 and 17% by dry weight. These values increased in later decades under optimized horticultural conditions, but served to establish a baseline for the original cultivar. Minor cannabinoids consistently detected include measurable cannabigerol, rendered cannabigerol, and trace cannabinol, rendered cannabinol. Cannabigerol levels indicate incomplete conversion during the biosynthetic window, a trait shared with other hybrid cultivars of the period. Cannabinol signatures appear primarily in aged samples due to post-harvest oxidation rather than genetic programming. The constant presence of Aussie mean, myrcene, humulene, and caryophyllene across preserved material taken from multiple decades demonstrates that Skunk Number One did not rely on phenotype drift for its identity. It established a fixed terpene ratio range that remained stable across indoor environments and remained chemically distinguishable from both its tropical and Afghan ancestors. The combination of elevated monoterpenes with inherited sesquiterpene markers is the defining biochemical characteristic of the cultivar. The first confirmed derivative cultivar produced directly from Skunk Number One through targeted backcrossing and selection was Super Skunk. Breeding documentation from the late 1980s shows that it was created by reinforcing the Afghan component already present in Skunk Number One rather than introducing new genetic sources. Analytical comparison of verified early seeds confirms increased calyx mass and higher total resin production relative to the parent line. Terpene distribution remains centered on Aussie mean, myrcene, and humulene, indicating that the augmentation process increased resin density without altering the defining chemical signature. The second established line is Shiva Skunk, produced by crossing Skunk Number One to Northern Lights. Chemical analysis of authenticated early material demonstrates a dominant sesquiterpene presence not found in the parent skunk expression. Myrcene remains present at functional levels, but caryophyllene concentration increases noticeably due to the Afghan ancestry of Northern Lights. This cultivar is historically significant because it represents the first recorded instance of two major foundational hybrids being combined to create a stable indoor cultivar, establishing a new structural template for controlled environment breeding. The third recorded derivative line is Skunk Number 11, which originated in European seed distribution networks during the early 1990s. Its creation focused on uniform internodal development and minimal phenotypic variation rather than increased potency or aromatic intensity. Grow cycle data taken from early catalog trials shows consistent maturation windows and repeatable canopy structure in controlled environments. Chemical testing indicates that terpene values fall within the standard Skunk Number One range, confirming that the line was not altered for new aromatic traits, but was instead selected for cultivation consistency. The fourth daughter cultivar is Early Skunk, produced for outdoor environments at latitudes where the original skunk flowering duration risked late-season loss. Breeding notes confirm that it was produced by pairing Skunk Number One with a faster finishing broadleaf line, while chemical assays show that the dominant terpene ratio remains identical to the parent skunk profile. The only documented change is a shorter photoperiod requirement to initiate reproductive growth. This represents the first verifiable case where skunk genetics were adapted for seasonal climates without structural or biochemical alteration. The fifth, historically confirmed derivative line is roadkill skunk, identified not as a company-issued cultivar, but as a consistent phenotype within early Skunk Number One seed populations. Archived testimony from independent growers in the 1980s describes material with extremely high, volatile terpene load, dominated by oxymene and related esters. Unlike later versions that shifted toward fruit-forward terpene profiles, roadkill skunk maintained a strong sulfuric aromatic output measurable during active growth. Laboratory analysis of surviving seed stock demonstrates that this phenotype is chemically distinct but genetically traceable to Skunk Number One without the introduction of external lineages. All 5 lines retain the same fundamental chemical markers that define Skunk Number One. Differences appear only in maturation timing, structural density, or environmental adaptability. None of the verified daughter lines contain terpene distributions that deviate from the oxymene, myrcene, and humulene profile range established in the parent cultivar. These 5 expressions represent the complete set of first-generation documented skunk derivatives that maintain chemical continuity while expanding cultivation function. The earliest verified genetic convergence between a Mazar line descendant and the skunk lineage appears in the documented cross of Northern Lights Number 5 and Skunk Number One during the early 1980s. Northern Lights Number 5 had already undergone controlled inbreeding in North America, using Mazar-derived Afghan stock that expressed dense broadleaf floral construction, high resin mass, and shortened maturation windows. When paired with Skunk Number One, breeders recorded that the resulting progeny maintained skunk's consistent branching architecture under indoor lighting while adopting Afghan resin thickness and reduced leaf-to-flower ratio. Chemical analysis performed on verified archival flower samples demonstrates simultaneous presence of myrcene levels above 0.6% and measurable oxymene content above 0.5% by weight, proving that aromatic inheritance was retained from both parents rather than overridden by one side. This hybrid marks the first point in the historical record where an engineered hybrid line and a stable Afghan export cultivar formed a chemically traceable union. The second documented convergence, later cataloged under the commercial name Shiva skunk, represents a second-generation pairing of Skunk Number One with a Northern Lights parent rather than a direct outcross. This hybrid is significant because it confirms that early breeders recognized the compatibility between the skunk framework and Afghan-derived structures and intentionally repeated the combination. Laboratory data taken from authenticated early Shiva skunk material confirms that sesquiterpene concentration, particularly caryophyllene and humulene, exceeds the levels present in Skunk Number One while retaining measurable monoterpene signatures absent from unmodified Afghan lines. This establishes that the hybrid did not simply blend 2 lines, but formed a reproducible chemical profile with inheritance traceable to both contributors. The third verified point of intersection occurred when super skunk selections were back-crossed into Afghan Number One, a direct seed line taken from northern Afghan hash cultivars during the late 1970s. Notes found in private breeder journals indicate that this work was conducted to stabilize canopy load under early, high-pressure sodium systems, which caused structural collapse in certain skunk-dominant selections. Seeds recovered from these projects display resin head diameter measurements consistent with Afghan Number One and terpene ratios matching Skunk Number One's oxymene-myrcene-humulene distribution. This is the first recorded hybrid in which a skunk-dominant chemical field coexists with fully restored Afghan resin morphology. The fourth confirmed lineage intersection appears in the early hash plant mixed with Skunk Number One line. Hash plant, in its original form, was a Mazar-derived selection preserved for its unusually high trichome mass and hand processing suitability. When crossed into Skunk Number One during the transition to formal European seed distribution, the resulting hybrid retained hash plants' dense gland production and physical resin characteristics. Analytical comparison of surviving research material shows elevated humulene and caryophyllene values above typical skunk ranges alongside detectable Aussie mean, demonstrating that terpene inheritance transferred from the skunk side without displacing Afghan biochemical structure. This hybrid represents the first documented confirmation that resin-dominant Afghan cultivars could retain their processing value after skunk integration. The fifth verified skunk-Afghan convergence is the line distributed as early skunk, designed for outdoor cultivation at northern latitudes. The Afghan contribution supplied the shortened photoperiod trigger needed to complete flowering before temperature decline, while Skunk Number One supplied the consistent branching pattern and aromatic volatility that allowed monitoring of crop readiness without laboratory testing. Regional grow reports from the early 1990s confirmed that the line completed harvest cycles in climates where unmodified Skunk Number One failed to finish. Laboratory assays performed on batch-preserved samples confirm that Aussie mean remained present at functional levels, while myrcene concentrations matched the lower range of Afghan-derived cultivars, indicating that both terpene signatures persisted in climate-adapted versions of the cross. Across all 5 intersections, the defining pattern is the retention of measurable biochemical markers associated with each parent lineage. None of these hybrids display full displacement of either Afghan sesquiterpene profiles or skunk-derived monoterpene signatures. Structural and environmental traits change according to breeding objective, whether indoor structural reinforcement, resin recovery efficiency, or outdoor season completion. But chemical identity remains traceable to both source populations. This convergence marks the first historically verified phase where natural selection-based Afghan genetics and engineered hybrid lineage architecture became linked in a stable, reproducible format. The direct hybridization between Mazar-derived Afghan cultivars and skunk-based hybrid lines created the first continuously traceable genetic bridge between naturally selected resin cultivars and engineered indoor production genetics. Before this point, Afghan export cultivars had been selected for their ability to withstand alkaline soils, low atmospheric humidity, and prolonged sun exposure. Their value was measured by resin adhesion, manual extractability, and storage stability under temperature fluctuations. Indoor skunk lines, by contrast, had been constructed for uniformity under artificial lighting, minimal phenotype divergence, and reliable maturation cycles unaffected by climate. When the two groups converged, selection criteria were no longer based solely on geographic performance. They became dependent on whether plants could carry forward Afghan resin traits while maintaining the structural predictability required for artificially lit production. This merger is documented chemically. Terpene distribution before convergence shows clear separation. Mazar and its descendant lines consistently display dominant myrcene and caryophyllene signatures, while Skunk Number One establishes a mixed monoterpene field with measurable Aussie mean and a secondary humulene presence. After convergence, laboratory records show recurrent profiles containing both myrcene abundance and elevated Aussie mean levels, accompanied by persistent humulene. This distribution is not found in pure Afghan resin cultures nor in unmodified skunk populations. Its appearance marks the beginning of a stable biochemical profile that remains detectable in modern hybrid cultivars 40 years later. The architectural traits associated with modern indoor cannabis production also originate at this convergence point. Prior to hybridization, Afghan cultivars exhibited dense bract stacking and high resin mass, but were often unsuited to controlled environment branching patterns. Skunk lines possessed consistent lateral branching, but produced lighter individual trichomes and less cohesive resin aggregates. Once combined, early breeders documented a shift toward compressed internode distribution, thicker petiole structure, and glandular trichome mass capable of maintaining integrity during forced air drying cycles. These changes are recorded not as aesthetic preferences, but as measurable improvements in post-harvest retention of gland heads during mechanical separation, which later informed solventless extraction standards. Breeding notes from the 1980s show recurring emphasis on the inheritance of processing weight, a term used informally to describe the ratio of usable resin to total biomass after trimming. This metric did not exist before Afghan skunk integration, because no previous cultivar population consistently produced high-density resin while maintaining controlled structural form under artificial lighting. Once hybridized lines demonstrated repeatable processing weight advantages, the metric became one of the central selection criteria for nearly every major indoor hybrid that followed. Modern solventless extraction yield benchmarks are descendants of the same measurement logic. Following the initial crossings, later breeders attempted to separate the two lineages again, but analytical chemistry demonstrates that this separation was never fully achieved. With each successive generation, even when breeders selected for fruit, dominant or floral dominant aromatic motifs, laboratory terpene assays continued to show the dual presence of myrcene and ocimene, supported by humulene or caryophyllene. These compounds form a biochemical signature of the original convergence event. Their continued appearance is a measurable indicator that the Afghan skunk integration became genetically locked into the breeding pool rather than functioning as a temporary hybrid phase. Modern cultivar names often suggest independent identities, but chemical fingerprinting contradicts this. Whether labeled as Kush, skunk, diesel, or hybrid, terpene chromatographs reveal combinations of Afghan-derived sesquiterpene markers and skunk-derived monoterpene volatility in ratios that can only exist due to the original merging of these two lineage groups. For this reason, any accurate reconstruction of cannabis lineage must define the Afghan skunk convergence as a single continuous genetic architecture, not a hybrid moment followed by divergence. Every widely cultivated indoor cultivar inherits from this event, whether or not its name, marketing, or regional reputation acknowledges it. The material presented here is part of an ongoing documentation effort that treats cannabis lineage the same way any agricultural history is studied, through verifiable records, structural traits, biochemical evidence, and the preserved accounts of those who maintained these cultivars before modern commercial naming practices existed. Nothing in this work promotes cultivation, transfer, or handling of cannabis in jurisdictions where such activity remains prohibited, nor does it instruct on how to produce controlled substances. The focus remains on historical, agricultural, and chemical continuity, not on consumer use. Cannabis remains regulated differently across federal, state, and tribal systems, and those regulations change according to jurisdiction. In regions where cannabis is legal for medical or adult use, compliance requires adherence not only to possession laws, but also to production, testing, packaging, and transport requirements. In regions where it remains prohibited, unlicensed cultivation and distribution carry criminal penalties. The historical and biochemical information presented here must therefore be understood as academic record, not operational guidance. The cultivars described existed and were documented long before modern regulatory systems, but current law determines how any part of the plant may be grown, studied, or distributed today. Individuals and organizations wishing to study cannabis genetics are responsible for ensuring legal compliance, laboratory certification, and proper chain of custody documentation for plant material. No part of this research should be interpreted as instruction to bypass regulatory structures or intellectual property protections associated with modern plant lines. Scientific and historical research into cannabis lineage is protected speech in most jurisdictions, but possession and production are not universally protected actions. Anyone wishing to engage with living plant material must consult local statutes, tribal regulations, and federal policy, including restrictions on interstate movement of cannabis or cannabis seed. Research-grade chemical analysis may require licensing depending on the jurisdiction and whether the tested material meets statutory definitions for hemp or controlled cannabis. This work remains strictly educational. Its purpose is to record lineage, structure, and chemical inheritance in a manner that preserves data integrity and reduces dependence on unverifiable folklore. Any use of this information outside legal, academic, archival, or regulatory settings is solely the responsibility of the individual or entity acting upon it.